Next example problem type are these ones where they give us the points. Now you could graph this out on graph paper, but that's going to take a lot of time. A quicker method is to treat it a lot like we treat slope. Remember how slope is back y minus front y over back x minus front x? Well, we're going to use those same calculations. We're just going to square them and add them together. So here we have back y minus front y, 0 minus 15. We have back x minus front x. A lot of you might have noticed that this one would be easier to go front minus back. So we could also do that. So we have negative 15 and negative 8. We're going to square these numbers. So we're going to go over here and we're going to write negative 15 squared plus negative 8 squared. Or, as I mentioned, why not turn these into positives? 15 squared plus 8 squared is 289. So we're going to square root 289 and we get 17. This distance is 17 units long. If you were to graph it, you would find that out as well. Here we're going to again go back y minus front y. 11 minus 7 is 4. 6 minus 3 is 3. 4/3 would be our slope, but we're not going to be using our slope. We're going to be writing it like this. 4 squared plus 3 squared. And we're going to square root that. 4 squared is 16. 3 squared is 9. Square root of 16 plus 9 is the square root of 25. We know that the square root of 25 is 5. So these are 5 units apart. The distance is 5. All right, we have another one. 14 minus 9, our back y minus our front y. 14 minus 9 is 5. And then in our slope, 4 minus 2 is 2. So we have a 5/2 slope. But we are not looking for the slope, we're looking for the distance. So we're going to write it as 5 squared plus 2 squared. 5 squared plus 2 squared, that's 25 plus 4, that's 29. So we have the square root of 29. Remember, the square root of 29 was up here. It is a prime number. We cannot simplify it any further.